Okay, let's take a look at problem number 2. Make sure I've got notes going. Here we go. Our equation here is y equals -2 times 4 to the x. So you can evaluate this by hand or in a calculator if you have a calculator available. So when our x value is -2, that would give us a negative 0.125. So what we're doing is just fill it in the table with all the values when you evaluate them. So you're just plugging in each of these values for the x and then evaluating. Make sure you follow your order of operations. If you're doing it by hand, you want to raise 4 to the power first and then multiply it by -2. When x is 0, we get -2. When x is 1, we get -8. And when x is 2, we get -32. Okay. For part B, it's asking us to sketch our graph using our points. When it says window, it really just means like domain and range. So our domain is going to be -4 to +4. Our range is going to go from -20 to up to +4. Just like on the last problem, the first point that I would probably plot would be the y-intercept, which in this case would be the -2. Because that's where our x value is 0. Okay, so I would just plot that point. Okay, and then if you can plot any other points, that would be awesome. So that's -2. I know when x is 1, we're down at -8. Let's see if I can make it fit. 3, 4, 5, 6, 7, 8. Not exactly equally spaced, but that's okay. And then at -1, we're at 0.5. And notice how we're getting really close to this x-axis here. So I'm just going to start kind of connecting these points together. And it's not great, but it's something. Okay? You kind of get the idea. All right. So our y-intercept, we already said, is at -2. So that means our y value is -2 when our x value is 0. And so on this one, since we're approaching this x-axis, but we're not actually touching it, notice how our values get really close to 0, but they don't actually get to 0. That means our asymptote is going to be the x-axis. And a big thing to remember is that the equation for the x-axis is y equals 0. Okay. Our domain is always going to be the same as long as we're talking about just an equation such as this, where we have arrows on both ends. You know, we're talking about all real numbers. When we look at real world problems, then we'll adjust that as needed. Okay, and then our range, this one's a little different because we're going down away from the x-axis. That means our y values are getting smaller. So that means our range now, instead of being y greater than 0, we're actually y less than 0.